Hello, I hope everyone is doing fine. And today I will be presenting the solutions of mathematics analysis and approaches standard level. This is from the recent May 2023 paper 1 time zone 2 exam. Now, right after the exam of this paper, I asked some students, and this is the response. And some even says the paper is brutal. Is it really? Now this makes me wonder, so that's why I thought I'll give it a go. Before we start, please keep in mind this solution was made before the official mark scheme was published by IB. So I recommend that you also try to solve this paper. Here we go. Paper 1. Please keep in mind this is a non-calculator paper, so we cannot use calculator for this paper. Number 1. The following diagram shows a circle with center O and radius 4 centimeters. Diagram not to scale. Points P, Q, and R lie on the circumference of the circle, and angle POR is equal to theta, where theta is measured in radians. The length of arc PQR is 10, so this is 10 centimeters. Let's do part A first. Find the perimeter of the shaded sector. So this section here, this is the sector. So the perimeter is equal to, obviously, 4 plus 10, this is given, plus 4. So the answer is 18. Next one, find theta. Remember this formula for finding arc length. L is equal to r theta. Arc length again is given. This is equal to 10 centimeters is equal to r theta. Radius is given, which is 4 centimeters. And theta is what we're trying to find. So theta is equal to 10 over 4, or in decimal, it is equal to 2.5 radians. Part C, find the area of the shaded sector. This is the formula for finding area of a sector. And we know the radius, which is 4. And we know theta. Here I use 10 over 4. Therefore, the answer is 20 centimeters square. Number 2, consider an arithmetic sequence with the first term, or U1, is equal to 0.6, and the fourth terms is equal to 0.15. A, find the common difference D. Now, this is the general formula for finding a particular term, UN. Yeah. And we are given the fourth term, U4. So let's use this. Yeah, so N is changed into 4. Yeah, U4 is equal to U1 plus, remember, N is 4. So 4 minus 1 times D. D is the common difference. The fourth term is given 0.15, this one here. And the first term, U1, is also given 0.6. Yeah. Plus 3D. And we can find D, the common difference. There you go. D is equal to negative 0.15. Next, the following table, this table here, shows the probability distribution of a discrete random variable x, such that probability of x is equal to n is equal to un over k. So for example, when that big X is equal to n, and n is equal to 1, so 0.6 over K. If n is equal to 4, therefore the probability when big X is equal to 4 is 0.15 over K. That's how we read the table. Now let's move on to the question. Find the value of K. In order to find K, we need to know U2 and U3. Now, knowing the first term and the common difference, we can find U2 and U3. So using this formula, we can find U2 and U3. We know the first term and we know the common difference D. After we find the second term and the third term, we can put these values into here. So we have these. Remember, these are all probability, and the sum of all of these is equal to 1 because the total probability is equal to 1. So we add these like so, and we equate these to 1. And then we can find K, which is 1.5. Number 3, a function f is defined by f of x is equal to 1 subtracted by 1 over x minus 2, where x is an element of real numbers, x is not equal to 2. Question A, the graph of y is equal to f of x has a vertical asymptote and a horizontal asymptote. Write down the equation of both asymptotes. Right, vertical asymptotes means we find the value of x that will make these equal to 0, so that this is undefined. Therefore, x is equal to 2. To find the horizontal asymptote, we can replace x with a very large numbers. If we do that, then the value of this approaches 0. Therefore, the horizontal asymptote is 1. Remember, your answer must be in terms of equation. Yeah, so must be x is equal to 2, y is equal to 1. You cannot just answer 2, 1. You will not get any point. So next, part B, find the coordinates of the point where the graph of y equal to f of x intersects the y-axis and intersects the x-axis. To find y-intercept, as usual, we set x is equal to 0. So we have 1 minus 1 over 0 minus 2. So that's equal to 1, 1 over 2, or 3 over 2. So this is the coordinate of y-intercept. To find x-intercept, we set y is equal to 0. So 1 minus 1 over x minus 2 is equal to 0. And then we can find x, which is equal to 3. So that is the coordinate of x-intercept. Part C, you are asked to sketch the graph of y is equal to f of x, showing all the features found in part A and B. So use all of these to help you sketch the function. We know the vertical asymptote. Usually we use dashes line to draw asymptote. There you go, that's the vertical asymptote, x equal to 2. And then we draw this, the horizontal asymptotes, y equal to 1. Again, use dashes line. And we know the y-intercept, 0.03 over 2, that one there. And we know the x-intercept, 0.30, that one there. And then sketch, that's all you have to do. So there you go. Number 4, events A and B are such that probability of A is equal to 0.4, probability of A given B is equal to 0.25, and probability of A union B is equal to 0.55. Find probability of B. This is a very common question in the exam. So we will use this formula here. Probability of A union B is equal to probability of A plus probability of B subtracted by probability of A intersection B. We know PA union B, this is given there. We know PA, this one here. We are asked to find PB, probability of B, but we don't know this probability of A intersection B. Well, we can use this conditional probability. Okay. Probability of A given B is equal to probability of A intersection B divided by probability of B. We are given this value, 0.25, this one here, is equal to PA intersection B over PB. Therefore, probability of A intersection B is equal to 0.25 B. Then probability of A intersection B is equal to this one here, 0.25 PB. And then we can solve for PB, which is equal to 0.2. Number 5, the following diagram shows part of the graph of y is equal to x over x squared plus 2, where x is greater than or equal to 0. This shaded region R is bounded by this curve, and the line x is equal to c. The area of R is given, which is ln 3. Find the value of c. To find the area bounded by the curve and the x-axis and this line x equal to c, we obviously use integral. So area is equal to integral from 0 to c, 0 being the lower limit or boundary, and c being the upper boundary of x over x squared plus 2, which is the function, the given function, with respect to x. Area is given, which is ln 3. Now, we have to manipulate this expression such that the top line or numerator contains the derivative of denominator. The derivative of this denominator is 2x. So we put 2x there. But remember, the original numerator is x. So we multiplied by 1 over 2. Therefore, the original expression of the curve equation is maintained. Now we can take half outside to end up with this expression, 2x over x squared plus 2. Again, if we differentiate the denominator, we get this 2x. Therefore, the integral of this expression is equal to ln of the absolute value of x squared plus 2. And then we put the boundaries, 0 and c. From here, we multiply both sides by 2, and we substitute the upper limit first into this expression, followed by the lower limit, and we subtract them. Therefore, we have this expression here. Simplify to get this expression. Now, I hope you remember one of the laws of logarithm. 2 ln 3 becomes ln 3 squared. And this is a subtraction of logs becomes logs of a quotient. Both of these logs have the same basis, which is base e. Therefore, we can equate these two expressions like so. Yeah. And then we can multiply both sides by 2 to get these. And if we open this absolute value notation, we end up with c squared plus 2 is equal to 18, or c squared plus 2 is equal to minus 18. And then we can solve for c. Let's begin with this one here. Here we have c squared plus 2 is equal to negative 18. Subtract both side by 2 to get c squared is equal to negative 20. So we reject this. Now moving on to this, we have c squared plus 2 is equal to 18. We subtract both side by 2 to get c squared is equal to 16. C is equal to plus minus 4. Therefore, C is equal to 4. Because here, C is located on the positive side of X. So we use C is equal to 4. So there you go. Question 6. The functions f and g are defined for x is an element of real numbers by f of x is equal to ax plus b, where a, b is an element of integers. G of x is equal to x squared plus x plus 3. Find the two possible functions f such that g composition f of x is equal to 4x squared minus 14x plus 15. Right. This expression can be rewritten as g of f of x. This means we input function f into function g. Function f is ax plus b, which is given here. So we replace x with ax plus b to get this expression. Yeah. Here we have x squared becomes ax plus b all square. Here we have x, so that becomes ax plus b plus 3. We expand ax plus b all to the power of 2 to get these, plus ax plus b plus 3. Now what we do is we equate based on the power of x. Now let's begin with x to the power of 2. From the left-hand side, again looking at x squared, we have a squared, so put it there. And from the right-hand side, looking at x squared, we have 4, so we can equate them. Therefore, a is equal to plus minus 2. Moving on to x, or x to the power of 1. From the left-hand side, we have 2ab and a. So we have 2ab plus a from the left-hand side, and from the right-hand side, we have negative 14. Again, we're looking at x, or x to the power of 1. But there are two values of a, plus minus 2. So we can start with plus 2 first. So substitute a with plus 2 to find b, which is negative 4. And then we substitute a with negative 2 to find b, which is equal to 3. Therefore, here are the two possible functions f. F of x is equal to 2x minus 4. Yeah, when a is equal to positive 2, this one here, that b is equal to negative 4. And when a is equal to negative 2, yeah, minus 2x, b is equal to 3. So f of x is equal to negative 2x plus 3. Moving on to section B. The following diagram shows part of the graph of a quadratic function f. The vertex of the parabola is at the point negative 2, negative 5, and the y-intercept is at point P. Question A, write down the equation of the axis of symmetry. Now this is very straightforward. All we do is just imagine there's a line that passes through the vertex, and that line is x is equal to negative 2. Answer must be in terms of an equation. Next, the function can be written in this form, where h, k is an element of integers. Write down the values of h and k. This parabola has obviously been shifted. It has been shifted by 2 units to the left and 5 units downward. H refer to the horizontal displacement, again in this case 2 units to the left, and K refers to vertical translation, in this case 5 units downward. So here is the expression where h is equal to -2 because the parabola moved to the left, and k is equal to -5 because the parabola moved downward. Next, find the y coordinate of P. P is the y-intercept. That is when x is equal to 0. So we substitute x equal to 0 into here, and then we can calculate for y coordinate, which is -4. Next, still number 7. In the following diagram, the line L, this line here, is normal to the graph of f at point P. Find the equation of the line L in the form y is equal to ax plus b. Right, so remember this is the equation of the curve f. To find the equation of a line, we need the gradient and we need a point. So let's apply calculus here. Given function f, we can find the gradient function by deriving this expression. Use chain rule to differentiate this expression to get half times x plus 2. The derivative of -5 is just 0. So this is the gradient function. The question says the line L is normal to the graph of f at point P. Now that point P has x coordinate equal to 0. So substitute x is equal to 0 into this gradient function to get the gradient of the tangent. From the gradient of the tangent, we can find the normal gradient, which is negative reciprocal, -1/1, which is equal to -1. Now that we know the normal gradient and we know the coordinate of point P, which is at point 0, -4, then we can find the normal equation using this formula. So there you go. That is the equation of line L. Y is equal to -x subtracted by 4. Next question. The line L intersect the graph of f at a second point Q. Calculate the distance between P and Q. So let's label the equation first. So that's the line equation or normal equation. And this is the equation of the curve. Since the line and the curve intersect, then we can equate the y's like so. And then we can solve for x. X is equal to 0 or x is equal to -8. X is equal to 0. Now this belongs to point P, but what we want is point Q. So point Q is actually when x is equal to -8. Substitute x is equal to -8 to either this equation or that equation. I choose this equation because this is easier in order to find y coordinate of Q. So there you go. We have found the coordinate of point Q at -8, 4. Then let's calculate the distance between P and Q using this formula. Therefore, the answer is 8√2 units. Number 8, consider an acute angle theta such that cosine theta is equal to 2 over 3. A, find the value of sine theta. Well, since this is acute and cosine theta is equal to the ratio of the lengths of adjacent side divided by the length of hypotenuse. Let's sketch our little triangle. Must be right angle triangle. And let's put theta over here. Therefore, this side is the adjacent side. This side is the hypotenuse. Therefore, we can find the length of the opposite side using Pythagoras, which is equal to the square root of 3 square subtracted by 2 square. That gives us square root of 5. Therefore, sine is equal to opposite divided by hypotenuse, which is root 5 over 3. So there you go. That's sine theta. What about sine 2 theta? Well, we need to use the double angle formula. Sine 2 theta is equal to 2 sine theta cos theta. We know sine theta, which is this one here, and we know cosine theta. Now this is given, that one there. So we have this expression simplify into 4 root 5 over 9. Moving on to the next question. The following diagram shows triangle A, B, C with angle B is equal to theta, angle A is equal to 2 theta, BC is equal to A, AC is equal to B. Show that B is equal to 3A over 4. This is not a right angle triangle, so we cannot use SOHCAHTOA. Our option is either sine rule or cosine rule. Here I go for a sine rule because it is the most suitable one given the information. So sine 2 theta divided by the length of the opposite side, which is A, that one there, is equal to sine theta divided by the length of the opposite side, which is B, give us this expression here. We know sine 2 theta from part A, and we know sine theta also from part A. And then we can rewrite these into this, and then we can cross multiply to get this expression, and then we can find B. So we have shown that B is equal to 3A over 4. Okay, next, still question number 8. BA is extended to form an isosceles triangle DAC with angle D is equal to theta as given in this diagram. Find the value of sine CAD. Sine CAD is equal to sine 180 minus 2 theta. And based on this formula, we can equate this to sine 2 theta. From part A, sine 2 theta is equal to 4 root 5 over 9. Therefore, sine CAD is equal to 4 root 5 over 9. Moving on to question D. Find the area of triangle DAC in terms of A. Area DAC is equal to half times B times AD sine CAD. We have found B previously, and that is equal to 3A over 4. And this triangle DAC is an isosceles triangle, therefore B is equal to AD. which is also 3a over 4. Sine CAD, we have found in part C, which is 4 root 5 over 9. Simplify this to get that answer. So there you go. Number 9, a circle with this equation has center at point 0, 0 and radius 3. A triangle PQR is inscribed in the circle with its vertices at point P, negative 3, 0, at point Q, x, y, and at point R, x, negative y, where Q and R are variable points in the first and the fourth quadrants respectively. Question A. For point Q, show that y is equal to square root of 9 minus x squared. We can use this formula, but our center is at point 0, 0, that's given there. And the radius is also given, which is 3. Therefore, we get this expression here. And simplify this expression to get x squared plus y squared is equal to 9. So y squared is equal to 9 minus x squared. Then y is equal to plus minus square root of 9 minus x squared. We just use the positive one because point Q is located at the positive y. Therefore, y is equal to square root of 9 minus x squared. So this is shown. Question B, henge. Henge means use the previous result. Find an expression for A, the area of triangle PQR in terms of x. Area of a triangle is equal to base times height over 2. Let's consider this side is the base and this is the height. Going from here to here is square root of 9 minus x squared. And going from here to here is also square root of 9 minus x squared. Therefore, this is the base. 2 times square root of 9 minus x squared. Moving on to the height. Height is equal to that point there, which is square root of 9 minus y squared, subtracted by negative 3. How to find this is easy. From here, rearrange such that x is the subject. And here what we want is positive x, because that point is located at the positive x axis. So there you go. That's how you find that x coordinate. So area of the triangle is equal to the base, that one there, multiplied by the height divided by 2. These two cancels out to end up with this expression. And we can replace y with that expression, square root of 9 minus x squared. The square root is gone. So we end up with that expression. 9 subtracted by 9 is 0. So this is the expression for the area of a triangle. Moving on to part C, show that dA by dx is equal to this expression. Well, we have found the expression for the area of a triangle in part B. So we can differentiate this. Let's assign u to this expression, and let's assign v to this expression. Therefore, u dash using chain rule is equal to minus x over square root of 9 minus x squared. And v dash is equal to 1. So dA by dx is equal to vu dash plus uv dash. and simplify to get this expression. Last question. Hence or otherwise find the y coordinate of R such that A is a maximum, that R coordinate there. This is an optimization question. So in this case, we can equate dA by dx to 0, like so. We can multiply both sides by square root of 9 minus x squared to get this expression. And then we can factorize to get these values of x. Now let's check which one of these values of x give a larger area. From part B, we have found an expression for the area, this one here. So we can substitute x is equal to 3 over 2 and x is equal to negative 3 into this expression. And in this case, x is equal to 3 over 2. Therefore, we can substitute x is equal to 3 over 2 into this formula in order to find y coordinate of R. So there you go. I hope this video helped.